So, till now we have discussed what are different type of signals and what are the different operation we can perform on the given signal. So, today we will see with the help of few numerical problems how we can apply different operations on the given signal. So, what is now as we have studied what is time advancement, what is time backward, and what is scaling, what is time folding. So, today with the help of numerical problem we will see how we are applying those operations on the given signal. Okay, thank you. Let us see. So, these are the till now whatever we have studied, from those things we can solve these different type of problem, which is first is synthesize the waveform using elementary signal. That means you are given any waveform like this. Suppose a waveform is given and you are asked to draw or represent this signal into elementary form or in mathematical form. Then how you will do? Then from the later in the second part where you are given a waveform and you are asked that identify whether which type of signal it is, whether it is energy signal, power signal, or neither energy nor power signal, then how we will do. Then third is finding average of any given waveform, then finding energy, finding power. Okay. So, as you know how can find average? Average is basically this is how we represent the average. Okay, this is the time. How we denote energy? Energy is represented by basically and if you are required to write for power, we write it like okay. So, these are the various three formula we use for calculating average, energy, and power. So, now see how we can. So, let us take few problems and see how we can solve the numericals. Okay. So, first let us solve the waveform problems. How we, suppose we are given a waveform and we are required to write the mathematical waveform of that given waveform, then how we will write. So, see, let us take first problem. Suppose there is one waveform given okay. Okay. Now, suppose this is a waveform given to you and you are asked that how you can write the mathematical form of this given waveform, then how we will do. See, if you divide, so we can see basically we can see that the waveform consists of see what are the three basic elementary signal we have studied. Basically there was three see till now we have studied basically three type of elementary signal. What are those? Unit step, then we have studied impulse, and third type was ramp. Okay. So, if you draw the waveform, this was the this is how we represent unit step, this is how we represent impulse, and this is the basic signal for representation of ramp. So, if you compare, if you try to divide this into elementary part, then we can see that this waveform consists of basically unit step signals. Okay. So, see how we can write mathematical form. See, suppose first you have to write this. For this, what we can write? If this is x t, we can write u t. So, if you write u t, then u t exists from what? 0 to t. So, it will go like this. Okay. But we have to terminate this unit step at 1. So, how we can do? See if we add a minus u t, at 1, then we can stop it to 1. So, what we will do? We will add, but see, if you want to subtract 2 unit step, then you have to write the step in negative amplitude. So, you can write u t, and this is for when you are adding a unit step signal at t is equal to 0, but now you are required to add a unit step signal at t is equal to 1. So, I will write u t minus 1. So, through this, so after writing this, what you have? You have this part. You have completed this part. Okay. Now again, you are required. Similarly, we can solve this for these two blocks. Okay. Suppose if you want to write for this. Suppose you want to write for this. This is 3. Then how you will do? See, first you have to make a unit step here. So suppose if you write for this, only for this block, then you can write u t minus 2. Why t minus 2? Because we are adding the step at what time? T is equal to 2. So we will write u t minus 2. Okay. Again, now we have to terminate this unit step signal at t is equal to 3. So what we will do? We will add a unit step of negative amplitude. Okay. Also here, see, the amplitude of unit step is 2. So we will add here 2. Now we are required to terminate this unit step at t is equal to 3. How we will do? We will add a negative unit step at time t is equal to 3 of negative amplitude. So what we will do? We will add minus 2 u t minus 3. So if we do this, then we can get this block. Similarly, we can write for this. So this is how we solve a unit from a unit step. You are required to draw something from unit step. This is how we will do. Now suppose, take another example. Suppose we have something like this. Basically, this is short-tooth wave. If you want to call it by a shape, this saw is known as short-tooth, because okay. Now suppose if we are required to represent this waveform with the help of elementary signal, then we can relate that this signal is made up of what? Ramp signal. So if you are required to draw, you are required to write the mathematical form. How you can write? This is suppose you have, I want to represent this, then what I will do? I will represent first this ramp. Suppose this value is 4, this is time is 1, this time is 2. Okay. So what is the slope? The slope of this triangle is 4 by 1, that is 1. So slope is 4. So basically 4 r t. So if I write 4 r t, what does it mean 4 r t? 4 r t will be like this. A slope, a signal with having slope of 4, a unit ramp having slope of 4 is 4 r t. But we require to terminate this ramp signal at t is equal to 1. So what we will do? Suppose if we now see how we will terminate. If you add a ramp signal of negative amplitude at this value, then what will happen? If you add a ramp signal of negative then what will happen? The final signal will become like this. But we are then it will go like this. But we are not going above this time t1, but we are dropping the signal at t is equal to 1. So other than this adding this negative ramp signal, we will be also required to add a negative unit step signal at this t is equal to 1. Then only we can make this. So see, 4 r t will give this, then minus 4 r at what time? T minus 1. Okay. So if we write if you add this, we will get like this. This is the final, but what we do? We are required to drop it at t is equal to 1. So what we will do? We will add a negative unit step signal, because if you add negative step signal, then if you will add, then it will come here. It will come like this. So what we will do? We will add a unit step of same value. Suppose now we will write u t minus 1, and the value will be what? 4, because here it is 4. So we will be required to add minus 4. So minus 4 r t. So if you combine this, you will get this waveform. Similarly, if you want to write like this, what we will do? See, the signal is same, just we have to time shift. We are required to shift it by 1. So how we will write? 4 r t minus 1. Okay. Again minus 4 r t minus 2, just shifting it by 1 second or 1 unit of time, and 4 r t minus 2. So, if we will add, if this is 1, this is 2, if you add 1 and 2, you will get this waveform. If you add 1 and 2, you will get this waveform. Okay. Now, coming to the third problem, suppose this was the combination of unity step and unit ramp. Similarly, we can do for the other signal also. Let us take one more signal. Suppose there is signal like this. Okay, there is a signal like this. Okay, here also suppose if you are, let it draw in clear manner. Okay, now, okay, so you can see this is 4, this is time is minus 1, this value is 4, this time is 1, this value is minus 4. Okay, suppose now if you are required to write the mathematical form of this given signal, how we will do? How we will do? See, if you consider, if you like to see, this is a ramp signal confined to a unit step between minus 1 and 1. This is a ramp signal. What is the slope of this signal? If you try to find out the slope, what is slope? Slope is m is equal to what? 4 by 1, 4. If you try to find a slope here, 4 by 1, this is minus 4 by 1, this is 1, this is 1. So, you will get here minus 4. Okay. So, basically if you can see this is a unit ramp signal confined to a unit step between minus 1 and 1. So, how we will write, like how we will write? See, first we will write RT, first we will be required to write this ramp. So, we will write 4 RT, and the ramp is where? From minus 1 is from t. See, if we shift the signal towards left, then we will add time. If we shift the signal to the right, we subtract time. So, we have shifted to the left. So, we will do 4 r t plus 1. Okay. Then this will, how we will write this? Okay, let us see. Let us solve first this. See, first we add this part, then we will do this part. We will do first this part, then in second part we will do this. Also, one more thing, if you see here, see how we have, if we are required to identify the signal, then we can say the signal is symmetric about origin. Okay, that means x t is equal to minus x minus t. So, we shall signal this if a signal satisfies this criteria, or if you remember, these are basically due to a signal. If a signal satisfies this criteria, it is called as what? Odd signal. If a signal satisfies this criteria, it is called as even signal. So, if you realize, if you try to connect, then which one is this? So, if you can see the signal is origin. So, this even signal and odd signal and even signal are basically represented. If a signal is symmetric about y axis, then it is called as even signal. If a signal is symmetric about origin, then it is called as odd signal. So, this is, if you try to identify, then this is the name of this signal. This is an odd signal. This is an odd signal. Okay. So, how we will write like this? Suppose first you have to make a step. So, how we will make this step? This step can be written as u t plus 1. Okay. And how we will write this step? This step, it will be u t okay, go to the next page. Now, third one, this was the some formula based on the waveform, how we are using the formulas or how we are using the basic signal to represent the given waveform. Now, if we are required to find the average of a waveform, if we are required to find the average of a waveform, that means suppose any waveform is given and we are required that what will be the average value of this, then how we will do. Suppose also you know what is the value of average. Basically in mathematical terms we represent average is equal to area upon time. Suppose there is some waveform like this and you are required to find the area. What is the area? Area will be, this is the length, this is height, and area will be what? Area is equal to half into length into height. This is area, and area upon time. Suppose this is the time, this is the time, this is the time that we can write upon t, then it will get average. So, area upon time is basically the average. Okay. Now, next. So, now take some problem average calculation. Suppose we have a signal like this, okay. A signal is like this. So, you can say that this signal is a what type of signal? This is a periodic signal. Why periodic? Because a elementary signal is being repeated on after every certain time instant. So, we can say that this signal is a category of a periodic signal. What is the relation of mathematical relation of a periodic signal? If x t is equal to x t plus t naught, then if a signal follows this, then you can call that signal is a category of periodic signal. Also, what is this t naught? This t naught is the fundamental time period. Fundamental time period. Okay. See, also one more thing here you can remember that, see, if a signal is periodic, for certain time duration, suppose if a certain time duration, for a certain time duration a signal is periodic, then that signal will be also periodic for n into that time period. For example, see, if you consider sine wave, so sine wave is basically periodic for what? This is 2 pi, the time period of sine wave, it keeps on repeating after 2 pi. So, we can say the 2 pi is the fundamental time period of sine wave. Now, if a signal is periodic for 2 pi, then it will also be periodic for n into 2 pi or n into time period. That is, it will be also periodic for, if a signal is periodic, see, this is fundamental time period 2 pi. So, if a signal is periodic for 2 pi, then it will also be periodic for n into 2 pi or n into t. You can write, if you keep value of n, it will be 2 pi, it will be 2 pi, 4 pi, 6 pi. So, if a signal is periodic for t, it will also be periodic for n t. Okay. That is why this is only the fundamental, it will be periodic for many time period. This one is the smallest, and the smallest time period for which a signal is periodic or it repeats itself, that smallest time duration is called as fundamental time period. So, what we were doing, we were calculating the average value of given signal. See, so also, so what I told, average is equal to what? Average is equal to area upon time period. So, how will, suppose this is this is what, a parabolic signal. So, how we represent parabolic signal? By t square. So, let us find it for a signal. So, also how we can calculate area? Area basically is what? By integration. Suppose if we want to integrate, suppose this is time 0, 1, 2. So, t square dt 0 to 1, 1 upon 1, then this is what? This is basically average. So, what we have done? We have calculated, this is the area, this is by time period. Area upon time period will give average. So, this is area. So, how we will solve it? We will solve it like this. It will be, if you solve the integration, it will 1 by 1. So, it will become 1 by 3. So, this is how we calculate area. Also, you can, if you take one other example, again if you are required to find the area of this signal, average of this signal, how we will do? We will find area upon total time okay. So let's find the area. So what is the area of this is square, it will be, sorry, this rectangle, the area will be 2 into 1. Also if a waveform is lying in negative y axis, then we will say that this area will be a negative area. So this is a triangle, so how you write area of triangle? Half into base is basically 1 to 3, that is 2, and height is basically minus or 2. So and by total time duration, so signal is existing from what? From 0 to 3, total time will be 3. So it will be 2 minus 2 by 3. Okay. So whatever is the value of positive area, same is the value for negative area. So area will be 0. Okay. So area will be 0. Now next thing, we have also discussed that any signal can be represented in form or summation of even and odd part. Okay. Any signal can be represented in the form of summation of even and odd part. So let us see how we will do. Suppose a signal is given like this. Okay. So let us prove this. See, suppose a signal is given like this. Time duration is like -2, 0, 2 and 4. Okay. Now suppose this is basically xt. So what is even? How we write even? How we write even signal? Even signal is xt plus x minus t by 2, and x odd will be x t minus x minus t by 2. So any signal this, then finally we can represent xt is equal to x even plus x odd. Okay. So what will be x minus, if this is xt, what will be x minus t? So x minus t will be like this. See, what is this? Basically this is time reversal. This is basically which property we are using, which signal operation we are doing? We are doing time reversal. So time reversal, it will be like this, x minus t. So if you add the signal, see xt plus x minus t by 2. So if you add the signal, what you will get? You will get even. So see, adding 1 and 2, this is 1, this is 2, adding 1 and 2 will get like this. You will get a signal like this. This will be the basically in the unit step you will get this will be the final x t plus x minus t. So see, if you have added x t minus t by 2, you have got this. It means if you realize this signal, then this is what? Symmetric about what? Symmetric about y axis. That is mean this is a even signal. Similarly, if you write x t, you subtract x t minus x minus t, then you will get a signal like this. If you subtract both, you will get like this. So see, subtracting x t minus x minus t will get odd signal, because how we will say this is odd? Because this is symmetric about origin. So you may be asked that represent or prove that any signal can be represented as sum of its even or odd part. Or finally, if this is x e and this is x o, if you add this signal, again you will get x t. If you add the signal, you will get x t. Okay. Now we move to the next point, that is identification of energy, power, or neither energy nor power signal. Okay. So, how we will do this? How we will do this? See, okay, in the next lecture we will see how we can identify if a signal is given or a waveform is given, then how we can identify the given signal is energy signal, power signal, or neither energy nor power signal. Okay. So, in next lecture we will see. Okay. Thank you.